In this video, we're going to talk about the intersection of two lines. For our first example, let's find the intersection of the two lines, or if you say this differently, let's solve the following system. So there are many methods for solving a system like this, and we're just going to cover one of the methods in this class. So what we're going to do is we're going to look at each equation one by one, and we're going to solve for y in each equation. So let's start with the top equation. If we started to solve for y, we'd say 2y equals negative 3x plus 2, and then we could divide through by 2. Say y is negative 3/2 x plus 1. So that's our first equation where we solve for y. Now we're going to work with the second equation and again solve for y. So let's subtract 9x from both sides. We'd have negative 2y equals negative 9x plus 18. And now we're going to divide through by negative 2. So we'd have y equals, well, when we divide negative 9 by negative 2, we get positive 9/2. So 9/2 x, and then 18 divided by negative 2, negative 9. So now that we've solved for y in both equations, what we're going to do is set y equal to y. We'll take y from the first equation. It was negative 3/2 x plus 1. And we're saying that's equal to y from the second equation, which is 9/2 x minus 9. So at this point, we want to think about clearing the fractions. Let's just look at all our denominators in this equation. The only denominator that we see is 2. So the lowest common denominator would be 2. And so we're just going to multiply this whole equation through by 2. So that is going to clear fractions from the whole equation. All right, so multiplying each term here through by 2, we'd have negative 3x plus 2 is equal to 9x minus 18. And now we've got a relatively friendly equation that we can solve for x. So let's move all the x's over to one side. We'd have negative 12x. And move all the numbers over to the other side. We'd have negative 20. So that tells us x is negative 20 over negative 12. And we can make that look a little bit better if we reduce that fraction. So both the top and the bottom are divisible by 4. We could actually divide through by negative 4. So we would have positive 5 over positive 3. So that's our x value. Once you figure out your x value, you can take that x value and sub into either equation. What we're trying to do now is find the y value. So let's look back up at our work. For the first equation here, we found y to equal this, and for the second equation, we found y to equal this. So we can sub back into either of the two highlighted equations, whichever one we think is going to be easier to work with. To me, they both look about the same, so I think I'll just choose the second one here. So let's sub into y equals 9/2 x minus 9, and so that tells us y is 9/2 times this x value that we found, which was 5 over 3, minus 9. Okay, so now we're going to do a little bit of work with fractions here. So when you have a couple fractions multiplied together like this, the numerators multiply and the denominators multiply. So anything from the top can cancel with anything from the bottom. You can cancel a factor of 3 from the top and the bottom. That just keeps the numbers a little bit smaller. So now the numerators multiply, get 15, and denominator 2 times 1, which is 2. Okay, so we got 15 over 2 minus 9. And that 9, we want to multiply top and bottom by 2 so that we can create a common denominator. So that 9 is going to be 18 over 2. In other words, y is 15 over 2 minus 18 over 2, so it's minus 3 over 2. And there we have the intersection of our lines. So we figured out the combination of x and y. Said x is 5/3 and y is minus 3/2. So I purposely chose an example that has algebra that's kind of tricky just to make sure that we're prepared for the worst case scenario. The algebra doesn't get any worse than that. So let's look back at the problem and make sure that we understood what we did. So the question asked us to find the intersection of the lines. Or alternative wording is to say, solve the system. So from a geometric point of view, what's happening here is that each of these equations in our system represent a line. We could make just a very rough sketch here. So we've got one line that looks something like that and another line that looks something like that. And what we've done is we've found the point where the two lines intersect. So that's what you're doing when you're solving a system, is you're finding the point of intersection of the lines. Okay, let's try a second example of solving a system. This time we were given the x value right off the bat. So x is equal to -1. And then we've got an equation for y. So to solve this, we're just going to take our known x value, x equal -1, and we'll plug it into the second equation, y equals -3x plus 2, and that's going to lead us to our y value. So y is going to be -3 times, we know x is -1, going to go plus 2, so y is +3 plus +2, which is 5. So this type of system ends up being very quick to solve. Our solution is, let's write it up as an ordered pair. xy is -1, 5. So in our next example, we want to find the coordinates of the vertices given the following feasible set. So you can see the feasible set is this region that's shaded here in the diagram. It's a triangular region. And the vertices just meaning the corners here. So let me put them in red. And we've got them labeled. We know they're called A, B, C. We've got a little bit of information in this diagram what the equations of the various lines are. So let's go about finding points A, B, and C. So let's start with point A. Let's think about what lines it's on. So point A is on the line x equals 0, which is this vertical line here. And it's also on this line -2x plus y equal 2. So to solve for A, we're trying to solve the system x equals 0, -2x plus y equal 2. So this is one of these systems that's relatively easy to solve. We know our x value right off the bat, and we're just going to plug it into the second equation. So subbing in here, you'd have 0 plus y equals 2. In other words, y is 2. So that quickly gives us our point A, which would be 0, 2. Point A, or vertex A, is 0, 2. So let's put all that stuff in a box, and we're going to do now the same thing for vertex B and for vertex C. So for the next one, let's do vertex B. I think that's also an easier one to just knock that off quickly. So if we look at vertex B, let's think about what lines it's on. So again, it's on the vertical line x equals 0. And it's also on this other line here, the 4x plus 2y equal 12. So doing the same kind of reasoning, we'd take our known x value, which is 0, sub it into our other equation, 4x plus 2y equals 12. And so that tells us that 0 plus 2y equals 12. In other words, 2y is 12, so y is 6. So we can say point B, or vertex B, is x value 0 and y value 6. Now the one that's going to require a bit more work is vertex C, because if you look at the two lines that it's on these two lines. And so we're going to have to find the solution to the system formed by those two equations. So let's think back to our first example in this video as to how we solved a system like this. What we said is that you're going to deal with each equation one by one and solve for y in each equation. So for the first equation here, if we start to solve for y, you could add 2x to both sides, and you could say y equals 2x plus 2. And then for the second equation, we need to work towards solving for y. So you could subtract 4x from both sides, and then you could divide through by 2. So every term now gets divided by 2. Y would be -2x plus 6. We go y equal y. So 2x plus 2 is the y value from the first equation. And from the second equation, y is equal to -2x plus 6. So now we have a little equation involving x that we can solve for. So let's add 2x to both sides. We'd get 4x. And subtract 2 from both sides, we'd have 4. So 4x equals 4, in other words, x equals 1. And then once you get your x value, you can go back into either equation. So look at these highlighted equations here. You can choose either one, whichever one you think is going to be easier to work with. I say maybe this one on the left here. So y equals 2x plus 2. So we're going to go 2 times, we know our x value is 1, and so y is 4. And that gives us our point C, which has x value 1 and y value 4. So let's just scroll back to the problem. Remember, the question was asking, find the coordinates of the vertices, or just find the vertices of the following feasible set. So vertex A and B were relatively quick. Vertex C took a bit more work. So this idea of finding the vertices of the feasible set, that's something we're going to be using in chapter 2. So we'll just store those tools away for now. So now we're going to look at a real-world application where we need to find the intersection of 2 lines. We're going to look at the idea of supply and demand. So what we're going to do is imagine that we're producing a product, like let's say cans of Coke or any kind of consumer product. The 2 variables that we're going to be interested in are the price of that can of Coke and the quantity that is being produced. So the price we're going to call P and quantity we'll call Q. We'll put quantity on the horizontal axis, price on the vertical axis. You may see this done in the opposite way in some textbooks, but in this case, that's how we'll do it. So when we talk about supply and demand, we're really thinking about things from first the manufacturer's point of view, that's supply, and then demand from the consumer's point of view. So let's look at supply first. Thinking about things from the manufacturer's point of view. So imagine we're the ones producing these cans of Coke. Here we've got quantity on our horizontal axis, price on our vertical axis. And what we're saying is the higher the price is, the more we are going to want to produce. So high price, high quantity, low price, low quantity. If the price is 0, we're not going to feel like making any cans of Coke. And as the price rises, we are going to feel a greater incentive to make more of this product. So the supply line goes like this. It's got a positive slope. Now let's think about demand. This is from the consumer's point of view. So now imagine we're the person buying the can of Coke or the iPod or the tablet or whatever the consumer good is. Let's think about how price affects how likely we are to buy that product. So when the price is high, if the price is too high, we do not want to buy any of the product. So high price means 0 quantity. And then as the price comes down, consumers are more interested in buying the product. And you can imagine an extreme, if a store puts on a ridiculous sale and some product is selling for a very, very low price, people are actually going to stock up and buy quite a large quantity of that product. So as the price comes down, quantity bought goes up. Got a negative slope. So if you put these 2 things together into a single graph, you've got your supply line that's got a positive slope, and you've got your demand line that's got a negative slope. And these 2 lines are going to intersect somewhere. And that point where they intersect is called the equilibrium point. So the equilibrium point is where supply equals demand, where there's enough of the good to supply the consumers, but there's not an oversupply, so the manufacturer doesn't need to pay a storage cost to keep the product in storage. So let's say there's some consumer good that's being manufactured. What we have is a supply curve, or a supply line, you could say. We've got the equation of the line, and we've got the demand curve, or the demand line. We've got the second equation. We're told that P is in dollars, and Q is in thousands of units. What we want to do is find the equilibrium price and quantity. So in other words, the question comes down to just solving the system. And notice that the way the question is set up, each of the equations is already solved for P. So we've got P on its own, P on its own. So it's just going to be a matter of setting P equal to P, and then we'll be able to solve from there. So from the first line, P is equal to 0.005 Q plus 2.5. And from the second line, P is equal to negative 0.002 Q plus 6.7. We're always interested in clearing fractions and decimals from an equation to make it easier to work with. So the right thing to do here would be to multiply by 1,000. See, each time that you multiply by 10, you're shifting the decimal place. So we want to shift the decimal place 1, 2, 3 positions. So we want to multiply by 10 and then 10 again and then 10 again. So that amounts to multiplying by 1,000. Let's multiply this whole equation through by 1,000 and things are going to look much better. So this first term becomes 5Q Second term becomes 2500. On the right side, negative 2q plus 6700. Okay, now we've got nice integer values to work with. So we could add 2q to both sides of the equation. We have 7q over here. And we could subtract 2500 from both sides. So we'd have 4200. And that's going to work out nicely. You can divide through by 7 and we get q equals 600. Then once you have your q value, you can go back into either equation. So we'll go q equals 600 into either equation. We'll just look back up at the question and decide which equation we think is going to be friendlier. I say top one looks fine. So subbing into p equals 0.005q plus 2.5. And let's figure out the p value. So p is 0.005 times 600 plus 2.5. And we can try this on our calculator. P works out to 5.5. So now let's just be sure that we're answering the question. What we want to do is find the equilibrium quantity and price. We were told something about units in the problem. So P is measured in dollars. So that's going to be our equilibrium price. And our quantity is measured in thousands of units. Okay, so just to keep the numbers small, Q is measured in thousands. So we could say the equilibrium price is $5.5, or you could say $5.50. And the equilibrium quantity is, it's not exactly 600 because the quantity is measured in thousands, so it's actually 600,000. So if the manufacturer produced 600,000 units of this product and set the price at $5.50, everybody would be happy. There would be just a perfect amount of supply. So last example, manufacturer A can produce a product for $300 plus $10 per unit. Manufacturer B can produce a product for $200 plus $12 per unit. How many units result in the costs being equal, and what is the cost? Okay, so just a little piece of terminology here. You don't really need to memorize this, but particularly if you've taken some economics or you will take economics, this $300 here, that's called the fixed cost. So that's the amount that the manufacturer has to spend at the beginning just to start production. Could be something like equipment or renting a space to work in or something like that. Whereas when you say something like $10 per unit, that's the marginal cost. So that's the cost associated with producing each item. So that could be something like the raw materials that you need for each item. So for manufacturer A, what we want to say is something like the cost is going to be, well, it's going to be $300 at the beginning, plus it's going to be $10 for every unit that they produce. So 10 times the number of units that they're producing. So that's sort of what the equation is going to look like. Now, we can make this look a little bit better if we use variables instead of words like cost or number of units. So let's let Y be the cost that will be measured in dollars, and we'll let X be the number of units that are being produced. And so instead of saying cost equals $300 plus 10 times the number of units, we can write this in a more familiar way, and we can just say Y equals 300 plus 10 times X, and then it looks like the equation of a line. So your cost is your fixed cost plus your marginal cost times the number of items that you produce. So that's just for manufacturer A. And then we're going to have a similar equation for manufacturer B. So we were told that manufacturer B cost them $200, that's their fixed cost, plus another $12 per unit. So for manufacturer B, their cost is going to be that $200 plus 12 times the number of units that they are producing. So there's our system of equations. And then we can rephrase the question. The question is saying how many units result in the cost being equal and what is the cost? Okay, that's just another way of saying solve for X and solve for Y. So it's really just going to come down to solving this system. So we can say this is our system here, and we're going to solve this in the usual way. Notice that we've already solved for Y in each equation, or that's already been done for us. So that makes things particularly easy. So we're just going to say Y equals Y. So from the first equation, 300 plus 10x. And from the second equation, 200 plus 12x. So we're going to subtract 200 from both sides. And we can also subtract 10x from both sides. So 100 is equal to 2x. If we divide through by 2, 50 is equal to x. All right, so half the battle is done. We figured out our x value, and we can put that back into either equation. So you can look up at the two equations we've got up at the top of the screen. Just choose whichever one seems friendlier. I guess I'll just go with the first one. Let's plug into y equals 300 plus 10x, and we'll get our y value. So y is going to be 300 plus 10 times 50. Can put that into our calculator. That's 800. So the question was, how many units result in the cost being equal, and what is the cost? So how many units? That was our x value. That was 50 units, and our cost was y, $800. So that answers the question. So if both manufacturers produce 50 units, both of their costs will be $800. So if you were to plot these two lines where x is the number of units, y is the cost, you get two lines with positive slopes, but the slopes are slightly different. B is the line with the bigger slope, A is the line with the smaller slope. So the interpretation here is that if manufacturer B makes a small number of items, they're going to come in cheaper than manufacturer A. And then at some point, the two manufacturers come in for the same cost. So if they both make 50 units, their total cost is both $800. And then beyond that, for larger number of units, B is going to end up being more expensive. A will come in cheaper. So that's our video on the intersection of two lines. Thanks for watching.